Okay, my name is Jae Hak Lee, working at the Ocean Circulation and Climate Research Center here. My talk is about the surface currents in the tropical Western Pacific observed by surface drifters. Okay, this map shows that status of global drift array in earlier this week. Shows that the total number is exceeded 1,000, and this color light blue means that deployed by our institution, and the drifters were provided by NOAA. So each country provided ship time and decide the location. And we deployed since 2012, and then every year we received 30 to 100 drifters from NOAA and deployed to Western Pacific or Southern Ocean. And this light blue circle shows that in the Southern Ocean here and the Western Pacific Ocean there. So I'll talk about some observation from these drifter trajectories. Okay, this talk is related to the three program or projects. One is Global Drifter Program by AOML NOAA, and MOF NOAA JPA project is between Korean government and the NOAA agreement. There is so-called JPA project, and we have the so-called Gaia project, and NOAA provide drifters, and this Gaia project provides ship time, and we decide the deployment site. And in this case, we deployed this 26 in 3 years ago, and 23 and 32 last year. And this map shows that the annual summary of the deployment whole drifters, 2014, 15, and last year. And marked by blue circle is deployed in Gaia project. I'll talk about the trajectories of these drifters. We have another project, Poseidon, and we deployed last year in the Southern Ocean. Okay, this map shows that trajectories of 26 drifters deployed in June of 2014. We deployed in here along 165 East line, where there are the tower array. We deployed 26, and after 18 months after the deployment, all drifters go to the west and then disperse north and south. And you can see very thick north equatorial current. The width is about 1,000 kilometers. And after deployment, 8 to 9 months after deployment, it reached to the Philippine coast and then separated into the Kuroshio and the Mindanao currents. I'll talk more about the region here, 1, 2, and 3. The first region is that the NEC bifurcation. You can see the part of them flows into the north, making Kuroshio, and the remnant moves going down, making Mindanao currents. This graph shows that in previous talk, the long-term trend of this separation of latitude is now going down, both in the northern and southern hemisphere. By using this graph is produced by using a numerical model and argo data, and also the seas height data. And recently, the trend is stopped. It seems that the trend shows some going up now. Anyway, that is related to the something changes in the circulation pattern of the atmosphere wind system. And also the one thing is that when it shifted northward, that is exactly the same as in the El Nino years. So during the El Nino years, that is bifurcation latitude moving up and north and then going down. And there is also the seasonal variations. There's winter time going down and summertime going up. Anyway, in this case, the drifters arrived here in March and April, and the bifurcation latitude appeared around 13 degrees north, a little bit shifted northward. I'm not sure this is related to the El Nino or not. 2015 was the El Nino years, so there is some possibility those El Nino may act to this movement, like this one. Okay, second point is the retrofraction of this mineral currents. You can see this mineral current reached down, moved downward, and then generally part of them leaks into the ITF region, and then part of them going to the eastward, making the north equatorial countercurrents. This one drifters reached to here. This one is the March, further south, on the latitude of the 5 degrees north. And next one is the reached in May. Is reached turn in the east in the May, so that there is some big movement of this retraction latitude. And this map shows that the historical drifters. And the blue means that the winter season drifters and turning point time. And yellow and this warm color means that the summer season. So generally, this mineral current, so retraction occurred in the winter time in the further south, and then the summertime moving up. So that is seasonal variations. And why it may be due to the wind system, change of the wind system. This is NSEP daily mean wind, the U component and the V component. In that case, you can see that this blue column is southward southerly wind, and the red column is northerly wind and southerly wind. So you can see those direction is changed in the springtime. So such kind of change may be due to the change of the wind systems. So that is we observed. And next one is the enhanced north equatorial countercurrent here. This is trajectories of the drifters, and this graph shows that current velocity. Different columns that different months. So you can see some velocity peak, and sometimes it exceeds 2 knots, and sometimes it reaches to the 4 knots, very, very fast in this case. And this figure shows that, again, NSEP daily mean wind in 2015, January to December, and Indian Ocean to the Pacific Ocean. This blue color means the easterly wind, like a trade wind, and the red color means westerly wind. And you can see some events of the westerly wind. We called it the westerly wind burst. And when there is westerly wind burst, and these drifters very fast move to the eastward. So each velocity peak, numbering 1, 2, 3, 4, is well matched with this westerly wind burst. That is some indication of the developing of the El Nino the phenomena. So that these all motors move to the the eastward, very fast, and then makes the accumulation of the warm water in the eastern side, and then we can see some development of the El Nino. Another drift also shows that there's some trend. It's very fast in this case. It exceeded 4 knots. So very, very strong current appeared at the time eastward. And until the late August, the very strong eastward current appeared. So that is certainly related to the El Nino. Okay, the next group shows that another drifters that deployed in August 2015. At the time, we deployed 23 drifters. And the location is, this one is overlapped in 2014, but this one is we deployed in the southern region. Anyway, the totally different figure in the previous trajectories. All the drifters moving eastward, the equatorial countercurrent, and then northern part shows that going further east. Southern group is the turn to south much earlier, and you can see some separation region. It's maybe the western boundary of the cold tongue, and you can see some turn to join to the gyre. All of this turning occurred December and earlier January of 16. And these two drifters shows that now going to west. 1 year before, there was a strong eastward current. And then now it moved to the westward. So certainly something changed in the equatorial zone in 2 years. Comparing with other groups, so you can see some variation of the current system. And I'll show you these two drifters. These two drifters going west in the zone between equator and the 5 north. At the time, the velocity is relatively weaker, and the wind system shows that no western wind burst. So all is normal years. All the trade wind is dominates. And this figure shows that the numerical model result from the OSCAR. It shows that the U component and the 3 months mean, the winter, spring, summer, and the fall, and 2015 and 2016. So it shows that the very great annual variation in the equatorial current system. So the dark red is consistent with the El Nino event phenomenon. And the last year, El Nino stopped, and this current shows that generally westward. This one is the meridional component. I'll skip. Okay, anyway, from our observation, we observed in 2015, El Nino year, northward shift of the separation latitude of the NEC, and enhanced Mindanao current, and the seasonal variation of the Mindanao current retrofraction. And we observed enhanced north equatorial countercurrent. This is correlated with the westerly wind burst. And the last year is a normal year in the view of the El Enzo. We observed south equatorial current, that is the westward current, appeared in the equatorial zone between equator and the 5 north. And now I explain some new plan to observe low latitude western boundary currents. This figure shows that this one is a review paper published 2 years ago. Shows the schematics of the circulation pattern. The blue means that the surface current, and the purple means undercurrents. There is some question mark here. That means that we don't know what happened there for the undercurrents. And generally, such kind of schematics observed by most of observed data and the numerical model data and satellite data and so on. This figure shows that the south of the undercurrent below the Kuroshio or Luzon current. But another papers published in JPO shows that the different direction, this red column is the undercurrent, this blue is surface current. So we don't know what happened for the thermocline current system at there. This one is the new suggestions for the undercurrent, just below the thermocline, and based on Argo data. And Pochu et al. Suggests that there may be banded structure of the zonal current, zonal undercurrent. Some undercurrent was observed from the data set, but some are not. So we are focusing on this low latitude western boundary current and the making dynamics of such kind of banded zonal undercurrents. So this map shows that the trajectories, column is set the speed. You can see very strong current, so Kuroshio here, and the Mindanao current. And there is splitting into the ITF and the North Equatorial counter current. And this one is measured by subsurface gliders by US ONR project. And this red column is the surface glider trajectories, and launched from the Palau and many years. And then they estimate the current speed like this one. And based on such kind of the literatures, we make a plan to mooring the ADCP and the CPICE along this 8 north line. The yellow circle is ADCP moorings, and triangle means the CPICE mooring. We have the 3 more moorings for CPICE now, and the Chinese research group has a plan also the mooring on the 7 north, so that there may be some large data set after 2 years after from now. Anyway, we have a plan to this October, the new ship, the research vessel Isabu, will depart from Guam, and then we'll make the ocean direction measurement there, and the CTT sections, the mooring, and there is another monitoring site for the Kuroshio by in-house, KIOST in-house projects. There's expected ship track. Okay, such kind of work in the Philippine EEZ area. So we need your help to obtain the permission for the observations. So we need some discussions at this evening. Okay, thank you very much.
Thank you, Dr. Lee. So we have time for quick 1 or 2 comment or question.
You showed some drifter trajectory about the bifurcation of equatorial or current. So this trend is corresponded or equal to the other observation trend from other data, other kind of data.
You can see such kind of the separation and the separation latitude movement from the numerical model result, like HiCom. And also you can see one thing is that in the northern part of the NEC, you can see very active measure scale phenomena, the eddies and the inertial motions. The southern part shows that very simple. There are no such kind of measure scale activities. There's very strong measure scale activity appeared, and certainly such kind of the separation and movement of this latitude. So it's related to the wind system. Many researchers argued about the wind system is very important to analyze such kind of dynamics. But for the undercurrent, this subthermocline eddy may be very important.
Okay, Dr. Lee, let's move on to the next talk.